We develop our own tools. We also develop our own plugins and our own web apps. Let me get my crystal ball. If I knew the answer, Yeah, AI, the buzzword. If any who's kind of watching this interview wants to apply to the studio,
if you don't know Rhino,
make sure that you learn Rhino. The biggest challenges for me in that project were kind of dealing with these two very different worlds.
Hi everyone, welcome back to PA Talks. Today we're excited to meet Pablo Zamorano from Heatherwick Studio, where he's spinning magic with computational and parametric design. We'll dive deep into how he started his journey in architecture and what it is like to push the boundaries of design with cutting-edge tools. Pablo will share some insider info on the challenges and breakthroughs of Heatherwick Studio's most iconic projects and how AI is starting to reshape the field. He'll also drop some wisdom on what young architects should expect and how to thrive in innovative design firms. We're recording this special episode right in the heart of London at Heatherwick Studio, so tune in, relax, and get ready for a fascinating peek in the future of architecture with one of the computational designers around. I hope you enjoyed the episode. Before moving ahead, let's take a moment and spotlight Pacademy, an online architectural educational platform dedicated to the exploration of parametric design, computational tools, and artificial intelligence in architecture. Pacademy serves as a bridge to advanced design techniques, fostering collaboration with pioneering architects and designers. Through the online courses at the Pacademy, we dive deep into the multifaceted world of computational design, engaging with a wide array of topics that push the boundaries of architecture. You can register and join the live workshops or watch the previous studio workshops recordings. Don't forget to subscribe to our YouTube channel and hit the bell notification so you don't miss any new uploads. So if you guys are ready, let's get into the podcast. Thank you so much, Pablo, for having us in Heatherwick Studio, such a nice office, and it's nice to meet you in person.
Yeah, very nice to meet you too, Hamid.
Thank you so much, appreciate it. So just to begin, let's go back a little bit and briefly talk about your history and how did you get into architecture? Was it like a childhood dream or something? And then how did you end up being at Heatherwick Studio?
Yeah, well, I mean, that was I will say quite a journey. So I'm one of these people that kind of wanted to be an architect when growing up, but I don't come from a family of architects, so I didn't really know much about it. So it was more like an intuition, I will say. I mean, my father is an engineer, so I think it's close enough. Yeah, I kind of always wanted to explore a bit more about, what design was and how would you able to kind of come up with ideas, to make buildings. But I really didn't kind of fully make the choice in going into architecture since the very last minute when I had to kind of pick up, a career after I finished school. But yeah, that's how I kind of start my life as a student, and this was in Chile because I'm from Chile. So I started in Santiago. And then I finished my undergrad there, and I got my license there. And after practicing a couple of years, I moved to New York, where I practiced for about 3.5 years before moving to London. And it was here where I went back to school, and I did Emergent Technologies and Design at the AA. And then stay here working for a few offices, first at SOM and then Heatherwick Studio.
That's great. Nice journey. And what are your responsibilities as the head of geometry and computational design at Heatherwick Studio?
So I look after a team of computational designers here in the studio that interact with projects in different ways. So I will say we focus first on project work, where we will be helping directly on projects to solve complex geometry issues or run simulations or come up with workflows or new tools that may basically solve complex problems. Okay. And then we also have a dedicated team that focus more on consulting, and they will again kind of chip into projects to solve very specific either geometrical problems or to run specific types of analysis. I'm talking about environmental analysis or other kind of required analysis that a specific kind of project may need. Then we have then we focus on applied R&D, where we develop our own tools, and that means that although everyone in the team kind of works in Grasshopper, we also develop our own plugins and our own web apps. So that's what we do kind of within applied R&D, and then lastly we share knowledge, so we also spend some time making sure that everyone else outside the team, basically in the studio, can skill up and become better at what they do and more efficient.
Mm-hmm. You said you're also developing plugins and specific type of softwares that you're using inside the office. How deep this computational and parametric design process goes in the office regarding the analysis, optimizations, more iterations, and focusing on morphologies, and how much deep are you using, and how important is it for the workflow of the generally inside the office?
Yeah, it's a good question. I think so. As a studio, we focus in coming up with ideas that can have a real impact, but we also make sure that those ideas can be realized. And at this very moment, I think our kind of main focus for computational design is early stages, basically allowing the exploration of these ideas, okay, but also helping the teams to make informed decisions, design decisions. So that means that you're not only exploring form because you like to kind of, come up with a very, very extreme kind of morphology, but also you want to understand whether, that option may perform well, in terms of environmental performance, but also in terms of the impact it will have in the people that will kind of use the spaces. So for instance, we have tools that measure the amount of visual complexity of design, and that is directly related with human emotion, basically. So those type of analysis that are focused on kind of early stages, and then when projects develop, the kind of the computational, I think, task migrate towards workflows and interoperability, and geometry rationalization mainly. And then when we have to kind of go back to analysis, we will rerun them, as the kind of design develops. But we will most of the time also be working with kind of external consultants that will kind of help us along the way. And then we'll keep kind of that conversation or that kind of collaboration going up until we get to fabrication. And so we have very skilled people in the team that can deal directly with fabricators and have experience kind of running projects from the computational side since very early on to, site.
Mm-hmm. And you mentioned this back and forth communication and collaboration between the teams and the feedback loop, and also the doing optimizations and passing the project over again and then getting back to that project at another stage. And how long does this last? Like, is there any constant communication, and how does this collaborative environment would work with other teams regarding that? You are mainly focused on the optimization, analysis, computational stuff, but there are also design teams that are focused on design. Can you discuss a little bit about this collaborative environment with other teams?
Yeah, absolutely. And I think this is one of the
most important,
I would say, particularities about our team in comparison to other teams, outside the studio. But we don't work in isolation. So when we work on projects, it's not that a project will say, okay, well, here is this kind of very complex stair. You take it, you develop it, ready for manufacturing, come back, and then the project is done. We instead try to kind of sit in with the project teams, during the design process, focusing in solving these specific problems, but from kind of within the design lens. So that means that the computational design team is made up of people that is actually designers as well.
Absolutely, absolutely. And you mentioned about the fabrication. Does your team have hands on the fabrication as well? How deep you go with the fabrication and make the documentation ready for the fabricating of the process? Or
yeah, so I think another good question there. So there are two, I would say, two routes. So usually, or in most cases, we take on design scope up until, let's say, SD, and then around between SD and GD, we usually team up with a local architect, depending on where we're working on, and then we collaborate with them. So some of, let's say, the detailing for fabrication, okay, may be in a way coming from our partner kind of architect. But that being said, we will be very involved in actually how those details work. And we will, in a way, carry the ownership of them till the very last minute. I think a good example of this is how we introduce making. So we use making in the studio since, we start an idea, because we have, you may have seen kind of our workshop downstairs, but we have a big workshop here. We try to use it as much as we can. And so we not only use it to produce beautiful presentation models, but we actually use it to produce prototypes. So we use it to do sketch modeling, to have visual mock-ups of ideas, at one-to-one scale, small portions of buildings. But then we use those to take very informed clues, to have really good conversations with either kind of the local architect and the fabricator, or the engineers and the fabricators, basically the kind of the wider design team. And that's how we were able to kind of carry on the very design intent to the very last minute, and so we don't, although we work in collaboration with, let's say, local architects, we own the design till the very moment where the building is open,
incredible.
Basically.
Yeah, incredible. Among the projects that you have done, I know some of them as well, which magnificent projects. Can you speak about the most influential of them, which you faced also many challenges as well? How did you overcome these challenges?
So, I mean, if I had to kind of pick a project in particular, so one project that is very close to my heart is Coldrop's Yard, which is just down the road here. Yeah. It was actually the first project I worked on when I joined the studio. Peculiarity about not only being located on a site across two different buildings, but also being a project where you have kind of traditional craftsmanship, in two Victorian buildings that are being connected by a very contemporary move, that bridge between them, and so all of a sudden you have to deal with complex geometry and kind of advanced fabrication in relationship with old craftsmanship, and very manual work, So the biggest challenges for me in that project were kind of dealing with these two very different worlds where tolerances are very different, and then access to technology and skills vary as well, So some parts of the building in the upper level were coming from Germany. Some of the main kind of superstructure was coming from the north of this country, and then, everything was covered in slate roofs, which is, a traditional craft that was done by a father and a son, by hand, basically. So you have all these kind of different layers of complexity. And I think that's kind of the beauty of design in a way, So it's not only and solely about computation,
Yes.
Or it's not only about one thing or another, but it's more about how all these areas interconnect in a way, interweave.
Yes. Speaking about the topic of the day, which is artificial intelligence, and it's now becoming almost a part of our design workflows. How you guys are using the AI, not just only image generation, but also on other stages of the design.
Yeah, AI. So the buzzword. I think, so we've been kind of working with AI for a few years now. I wouldn't say that we are kind of the first adopters ever. No, it's not about that for us. But we've been researching about the technology for a few years, and the main reason is because we wanted to understand how this technology could impact, what we do. Try to understand whether it can give us or generate a positive impact, or it may have risks or pose a little bit of both. And I think, and that involved getting used to the technology, learn how it works, in a way, learn how to control it. And so it took some time, but we had, I would say, the lack of engaging with this technology in partnerships, in really good partnerships. So the first time we say, okay, well, what if we were to use this technology to kind of interact with our own sketches, and then help us to kind of drive an idea? And we say, well, why don't we run a little hackathon? We invite a few engineers, and then we do it together. And that's what we did. That was the first time we come up with an AI tool working with Thornton Tomasetti. And that really, I think, opened a huge amount of opportunities for us. So we realized that we could get to a quick sketch or a quick result very quickly if we engaged with the technology properly. And so that kind of kicked off many branches of exploration. And from that kind of time to now, now we have, as I mentioned, tools that deal with human emotion and visual complexity, and they're using computer vision. So different types of AI, to our own custom image generation tools. So we have our own custom tools, that work with our intelligence, with our styles, are tweaked by us, and we can decide how we use them. So we try to, in a way, engage with the technology, not because we like AI, or we want to kind of brand ourselves with AI, but rather it's because we understand the benefits it can bring, and we have learned how to interact with it, So now it's less about the technology, and it's more about what you can do with it.
Yes.
And so that's kind of in a nutshell, but we are engaging with this across the board. So it's not even only for design, So as a studio, we see many opportunities to actually leverage this technology.
What kind of future we can see or we can expect in the next 5-10 years with this technology in our industry? Maybe that's a little bit going too far regarding the pace and the speed of this technology that as it develops. 2 years ago, we maybe didn't have even any of these diffusion models or any of these LLMs, but yeah, right now we have so much developments, even compared to last 2 years. But architecture generally is a slow process, and it hardly adapts, or it takes time to completely integrate a new tech in this process, and also much harder to accept it in the construction and fabrication industries. And So I think in that regard, if we can say 5 years in AEC industry, what should we expect to see in the next 5 years?
Let me get my crystal ball. If I knew the answer, maybe I will be doing something else, reading
But again,
tarot.
there are suggestions
One of the things, as I will say you rightly mentioned, it's this relationship between kind of design and fabrication and construction. So there is a gap there. There is a gap, and the construction industry needs to catch up. Needs to catch up because everything else is going to change. And this is not a new tool. This is not the new software. This is not, it's not, I don't know, a big name coming up with a new solution. This is a technology that's going to disrupt everything we do. That's going to truly change the way we do things, and that's going to have an impact in how we build stuff as well. So that industry needs to catch up. And I hope, at least, I cannot tell you whether it will be like that, but at least I can tell you that I truly hope that in the next 5 years, construction is gonna start leveling up, with design, so we can actually get this whole new universe of ideas, coming from kind of AI-aided design, onto site.
And what do you think, how should architectural education systems should have their changes so they can adapt to the new paradigms in the realm of architecture and design? As an instructor who has been instructed in many universities, and I've seen your lectures as well, so maybe you can just give us some insights on that.
Yeah, I mean, I think it relates to the very same topic. Even the kind of the course I do at the AA is called Between Digital and Physical, So it really sits in this space where ideas start becoming reality, and the journey between understanding what are you dealing with to actually getting it done. So I think in terms of the skills, I think architects are lucky in a way because I believe we are somehow more open-minded about exploring things, and I think we're forced by our profession to come up with solutions to problems that may vary constantly, so we don't fear kind of the whiteboard, right? And that means that if the profession changes, and I think it will, changes in terms of our tasks, we will adapt, and we will prioritize or put. So I think it's more about understanding what things you prioritize, for a tool to do versus the things that you prioritize as your own values and, and where you put your vision, So hopefully in a Flash Gordon universe, we'll have this amazing technology that will leave more time for us to actually think about other things, how can we increase our impact? How can we make better ideas happen? And so on, become more human. So in one hand, I think it's good to let the students know and learn new tools, interact with new tools. But on the other hand, I think, and even more important, I think, is for them to understand how crucial critical thinking, is and will be. So the faster the technology pushes new to new ideas or new solutions, the more key critical thinking is going to become to understand what things are, good or not, what things make sense or what things may have a positive impact or a negative one, So I think it's not necessarily a conversation about the tool itself. Also, the tools will change,
Of course.
The way we use, Stable Diffusion today is going to be completely different to the way we use it in 6 6 years down the
Yes.
line. Maybe we will be talking about other type of technologies. So I think it's more about understanding change, embracing change, and then making sure that you prioritize critical thinking.
Absolutely, and the way technology evolves in itself is also another topic that we we can cover, and it's have its impacts into other disciplines. It's like it happens gradually, and disciplines need to adapt at some point. You've also started teaching some workshops to young generations and like kids, which I hijacked the name, which is called Heatherwick Inspires. So can you talk a little bit about that?
Yeah. So Heatherwick Inspires is not, I will say, is not an idea that comes from the computational design team at all.
Yes.
Okay, so this is more something that we truly care as a studio. And what Inspires are, it's basically a group of people in the studio that has been running workshops with secondary school students, mostly from local schools, in the area, where they can come to the studio and spend a day with us, kind of trying to experience a little bit what a designer's kind of day looks like, and we help them to kind of explore their creativity in a way, so we give them the space, and a bit of mentorship, so they can also see that there is a future, if they want to kind of embrace creativity through, let's say, the lens of design.
Absolutely. This is a great idea because back then there was this hype about architects, and I don't know what happened, but everybody has lost interest in the last couple of years. They don't like this building a role model as a architect, so the younger generation can inspire. That's something bad, actually, but I think creating role models in any industry would just help the youngsters to catch up and dream about becoming an architect, becoming a doctor, becoming a scientist. If we can't have that, what are these youngsters are going to inspired by? So yeah, congratulations on that note and giving some space to the kids and youngsters to inspire. One question that I wanted to go back and ask about the tools. What kind of computational tools and parametric tools are you using?
Yeah, so we are a Rhino-based studio. So our main design tool is Rhino. So if any who is kind of watching this interview wants to apply to the studio,
if you don't know Rhino,
make sure that you learn Rhino. And what I mean by that is not how to build kind of boxes with it, but actually to explore complex geometry with Rhino. That's our favorite tool. We have a large percentage of designers in the studio that can also use Grasshopper. And we use it mainly every project we design, there's no project that we've designed that did not require computational design. So everything we do requires computational design. That does not mean that the outcome will be parametric. That will be ridiculous, I think. It's more about how you handle complexity. And so Grasshopper is a tool, definitely everyone in my team, but I think across the board, it's a tool that everyone kind of try to learn at some point at least. For documentation, we use Revit. So we have a strong BIM team in the studio, but we also have designers that are good Revit modelers. And I think in the way we interact between the two software varies. So we have very well-defined kind of interoperability pipelines between them, mainly using Rhino Insight or another tool that is called MKS BIM, I think, depending on the level of, I would say, skills you have. So for computational designers, Rhino instead will always be kind of the one to pick, because you can keep control. But we have developed very, very good and fast workflows, so we can constantly kind of change drawings, from Rhino in a way,
Yes.
But yeah, so I would say documentation tool, Revit, design tool, Rhino. The other thing that is important to point at is that we never stop using Rhino. And the reason, across the whole kind of design stages, And the main reason of this is because we never stop designing.
Yes, good thing.
We never stop designing. And we never stop designing because there is always opportunities in the process. So you may have one part of your building be value engineered, for instance, or you will have a suggestion to value engineer part of your building, and you can say, well, this part really is the key element of the design, and we can compromise that. But there are other areas where you can actually compromise, and we try to re-explore those. What if we do this? What if we do that? Or if you save some money in one part of the building, then can we relocate part of that pot somewhere else? And all of this thinking, which is, design thinking, we explore in 3D, and for that we use Rhino. So our, if you want to call it digital twin, it's always a Rhino model. So our Rhino models are way more detailed than our Revit models.
Do you also create real-time models for buildings?
Yes.
After they get built, or?
Yeah, so that's a good point. So
how to monitor the data?
Visualization is one of these worlds that is changing at a rapid speed. I'm pretty sure that if we have this conversation in a week, in a year's time, we'll be talking only about AI. But it's not yet there. But we did have like big jumps. So Enscape, for instance, everyone uses Enscape in the studio. It's very easy to use. It's fully integrated into Rhino. Happy days. We don't have to jump into a third-party kind of software. So yeah, so that means that if you want to do a VR kind of walkthrough, you just plug the headset, and your laptop,
and you're there.
Sure, the quality is not going to be as good as Unreal, for instance, but the results will be much quicker. So for quick design decisions, is a really good tool. That being said, we do use Unreal, and so we have actually one Unreal specialist in the studio. She's called Sylvia, and she does really incredible Unreal animations. Mostly for kind of client presentations or final kind of presentations of projects, but she also kind of introduces kind of Unreal across kind of different, I would say, kind of stages of design.
Incredible. How large is your team, the computational team?
Yeah, so we have so the team is about 6 people. That's the core team. And then we have kind of a wider team of computational designers that take us up to 15 at the moment.
Great. And with all these experiences in teaching and academia and practice, leading the teams and hands-on real-time computation, massive projects, what kind of advice would you share with the enthusiasts in architecture, in computational design, and generally who they want to also pursue their career as an architect?
I think these are really exciting times for people that want to kind of go into, I would say, the design world. I think we're facing a moment where I'll say the architecture career is going to blend much more with other areas of design. I think that's the opportunity we have in front of us, and I think if you have a kind of a computational driven mindset, you are very well set up to actually open your opportunities. not only to think in, an architect as someone that designs buildings, but actually someone that can think, in a more kind of system kind of way, But I will also argue that, if you're not driven by computational thinking, you're also in a good position,
Yes.
and design, it's open into many, many different directions at the moment. So I would say regardless, it's important to skill up, but it's more important to understand where you are, right now in the world, and where is the world, at one particular time. But yeah, be ready to change. If you feel comfortable in a kind of constantly changing environment, and using your creativity, to engage with that, to actually have a positive impact in the world, I think this is the place. One thing that I didn't mention, in terms of the type of tools we develop, because I think everyone is very excited about what's happening with AI, and everyone wants to kind of label themselves with AI somewhere there, and there may be good reasons for that. I don't know, but the tools we produce are focused in solving the right problem. Okay, and I think that's the first priority before you pick the technology you use. So for instance, the tools we have developed for Rhino have aided two main things. One is design tools. Tools that allow you to model quickly things, or to detail models quickly, and then tools that bring some of the BIM world into Rhino. So we have developed our own BIM tools for Rhino. And these are not linked to, well, they are linked to Grasshopper. You can also use them from Grasshopper, but these are not Grasshopper tools. These are fully Rhino plugins. And so in that way, we can add parameters to objects. We can organize our buildings by levels. We can, kind of generate plan sections and elevations from them. But we can add as many information to any type of geometry we deal with, and that can be ported, to whatever other software, So what I want to say is that kind of the tools we work on are more focused in solving the real problems we need to solve.
You mentioned you developed these tools internally with the team in the office.
Yeah. So some of the tools are fully developed internally. So we have some of these Rhino plugins, for instance, have been developed internally. We have really good people for this. Alfredo, if I can name one, is a huge champion of our internal tools. But we also partner with external developers, and we work in collaboration. So we have worked with Reope, for instance, in Norway, to develop some of the tools, particularly a tool that we call Metrics, that brings some of these BIM interactions into Rhino. But we have also worked with MKS to work on web apps. We have a web app that let you measure visual complexity of any geometry, and we did that in collaboration with them. But we're also working with other people, doing, for instance, now a few AI tools, and in the way we work is usually we will, because we have a small team, we will get to a working, some tools we fully develop in-house, but I would say the bigger ones, we tend to get to a working tool in-house, and then we'll take it to the next level with an external partner.
No, I mean, incredible. And are you making any of these tools publicly available?
So
for the good of architecture?
Some of them will. So we have one tool that that we're still developing that is connected with a new book we released recently that is called Humanize, and that's a tool that will allow anyone to kind of measure and score visual complexity on any design, and that's linked directly to the impact on the emotion that it will generate.
My key point there was, we as architects, when we develop tools, we keep them for ourselves. But engineers, they do it, they business it, and they offer us the tools. Most of the times, they don't understand architects' needs. But when we do it, we don't share, or because, I don't know, because we're not probably, we don't want to share secrets or stuff.
That tool that I mentioned, we're releasing to the public.
With the Humanize book.
Yeah.
That's cool.
And then, and there may be a couple more, but I cannot.
Okay.
I cannot talk more about
eagerly waiting. So until we publish the episode, probably they'll be out there.
Hopefully.
So yeah, looking forward to it.
Excellent.
Thank you so much, Pablo.
Thank you. Thank you,
Nice
Hamid.
to talk to you. Thank you. Appreciate it.
Good to have you here.
Guys, thank you so much for watching the episode. I hope you enjoyed it a lot. Again, I want to spotlight Pacademy, an online architectural educational platform that spreads the idea of using parametric design, computational tools, and artificial intelligence in architecture. You can register and join the live workshops or watch the previous studio workshops recordings. Don't forget to subscribe and hit the bell notification so you don't miss any new uploads. Thank you so much for watching the episode. Hope to see you soon in the future episodes.